Hello everyone, welcome to chemistry classes. So today we are going to discuss about the important bit of this topic, that is secondary battery. Secondary battery. In the previous class we have discussed about primary battery. So what is the primary battery and the examples we have seen about the specific examples of primary battery. And now we will discuss about the secondary battery. And already yesterday I have in the previous video I have mentioned that a battery means what? A combination of two half cells will form a cell. The combination of a large number of those cells in series gives a battery. Okay, so this battery is used as an energy source. Now, so we'll discuss about secondary battery. What will be the secondary battery and how it functions? Okay, a battery which can be rechargeable. A battery which can be rechargeable and reusable. The battery which can be rechargeable and reusable is called as secondary battery. So secondary battery means what? A battery which can be rechargeable and reusable. So in case of primary battery, in the previous video we saw that primary battery. In primary battery what happens? A chemical reaction takes place only once during its lifetime. So after the use of some specific time of period, the battery becomes dead. Now this battery is not like that. We can use this battery again and again and again because they are reusable. And in those days you might be seeing that the camera cells are there, the batteries for the photographic cameras, so those can be rechargeable. Like that, a battery which can be rechargeable and can be reusable is called as a secondary battery. A good secondary battery can undergo large number of discharging and charging cycles. So once a battery is charged, we can use that. During use of that battery, the charge is discharged. So after the complete discharge of that battery, we can recharge it again. So like this we can use that battery again and again. So during charging of that battery, the chemical reaction reversed, and during discharging the spontaneous chemical reaction takes place, isn't it? A secondary battery function as a electrolytic cell during its charging, and it function as a galvanic cell during its discharging, isn't it? So please remember that. The best example of the secondary batteries are lead storage battery and nickel cadmium battery. The best examples are lead storage battery and nickel cadmium battery. So first let us see what is lead storage battery. You might be seeing that the motor vehicles, automobiles and cars, and in the inverters in the home, we use a large battery. So that battery is called as lead storage battery. In inverter we use a large battery. That battery is called as lead storage battery, isn't it? Cuboid shaped battery, lead storage battery. In automobiles also we can see the various size of lead storage batteries. They are of the small size and they are of the large size. Large sized batteries are used in four-wheelers like cars, buses and lorries, isn't it? Like that. And the small size batteries are used in our automobiles, bikes. So it consists of let us see what will be the lead storage battery. It consists of lead anode. In lead storage battery, lead function as an anode and lead packed with lead dioxide. Lead packed with lead dioxide PbO2 behave as cathode. Yeah, so this is important because in examination the question will come like that. Say what is the anode in lead storage battery? So what is the answer? Lead behave as anode in lead storage battery. And what is our cathode? A cathode is the lead packed with lead dioxide PbO2 as cathode. A 38% solution of sulfuric acid behave as electrolyte. So in lead storage battery, 38% of sulfuric acid behave as electrolyte. So you might be seeing that in some batteries, some used to say that the battery is drawn out. So we have to add some water to that, battery water, isn't it? On this battery battery ನೀರು ಖಾಲಿ ಆಗಿರಬಹುದು, so ಅದಕ್ಕೆ ನಾವು ನೀರು ಹಾಕಬಹುದು ಅಂತ ಹೇಳಿ. We can add which water? We cannot add tap water to that battery. So we can use only double distilled water to that battery, isn't it? So 38% solution of sulfuric acid behave as a electrolyte in the lead storage battery. The cell reaction when the battery is in use, when using that battery, the cell reaction takes place like this. At anode, anode means at lead, which reaction takes place here? At anode, lead is present. Lead react with sulfate ions given from the sulfuric acid. The sulfate ions are given out by the sulfuric acid. They will interact with lead, and at anode oxidation reaction takes place. Here lead is 0, here it becomes +2. So the lead react with sulfate ions to form lead sulfate by using 2 electrons. So oxidation reaction takes place at the anode. So these electrons are captured at the cathode. At cathode, what we got? We got lead oxide, lead packed with lead oxide, lead dioxide. This lead dioxide also interact or also react with the sulfate ions given by the sulfuric acid in acidic medium, because we have added acid as an electrolyte. So the medium of the reaction will be acidic only. In the presence of H plus ions, the reduction reaction takes place. So during reduction, what happens? The lead dioxide forms lead sulfate, and the 4 H plus ions undergo reduction to form water, isn't it? So these are the chemical reactions. These are the most important chemical reactions. Please remember, these reactions are oftenly asked for your board examination. Here in 2018 also they are asked, in 2017 also they are asked, I think. Okay. So these are the important chemical reaction takes place in the battery. So these two reaction takes place when the battery in use, means when we are using that battery. In that condition, these chemical reaction takes place. Means in use means what? Which condition it is? Discharging condition. In discharging condition, these chemical reactions takes place. So what will be the overall chemical reaction? How we can write overall chemical reaction? We can write overall chemical reaction. See here. So just I will remove this. Overall chemical reaction is, I will remove this word. The overall chemical reaction is. See here. What are the possible things we can cancel out? We can cancel out electrons, 2 electrons and 2 electrons, and we cannot cancel any other terms. Okay, so let us write what are the remaining things present at the reactant side. On reactant side, on the product side, they are written on the product side. Pb is remaining, PbO2, SO4 2 minus, SO4 2 minus, means how many? 2 SO4 2 minus ions are here and 4 H plus ions are here. Means 4 H plus ions, 2 H plus ions, 1 sulfate ion combined to form H2SO4, isn't it? Here the 4 H plus are here and 2 SO4 2 minus are here. So we can directly write 2 H2SO4, isn't it? So we can write 2 H2SO4. PbO2 plus 2 H2SO4 gives PbSO4 plus PbSO4, 2 PbSO4 plus water. So this is the overall chemical reaction taking place in our battery when the battery in use. Battery in use, using that battery means discharging condition. So what happens if the battery is charging? If we keep the battery to the charging, what happens? The entire chemical reaction reversed. The chemical reactions are reversed. Reversing means what? The lead sulfate formed at the anode reversed. It gives back lead at the anode, and this chemical reaction also reversed during its charging. What happens? At the cathode we are going to get lead dioxide. So again we got the same reactant as before. So after that what we can do? We can use that battery again. So during use of that battery, the same chemical reaction takes place. Lead is converted into lead sulfate, and lead dioxide is also converted into lead sulfate. So after then again during charging, the reverse reaction takes place. So like that we can use this battery for longer time. It has got long life, isn't it? So, and one more important thing, one cell of lead acid battery has a voltage around 2. Actually 1.98 something like that, but we can consider it as that it has voltage around 2, one cell. So such a large number of cells are present in one lead storage battery. Okay. Next, the next important is nickel cadmium battery. Nickel cadmium battery. So here it has a large life than, large means longer life than the lead storage battery. It is also important secondary battery. It is more important than lead storage battery. It has got a longer life than lead storage battery, but the problem is it is more expensive to manufacture. The manufacturing cost is very much higher. So because of that reason, we cannot use this battery in our automobiles, isn't it? So we use this battery, lead storage battery, in our automobile. The overall chemical reaction taking place in the nickel cadmium battery is cadmium nickel hydroxide gives cadmium oxide and nickel hydroxide and water. Here this nickel hydroxide is converted into trihydroxide is converted into dihydroxide, isn't it? So the chemical reaction of lead, that nickel cadmium battery is somewhat complex, so we cannot go deeper in that. We cannot go in depth of this nickel cadmium battery. Okay, so please remember these two are the important secondary cells. So this is about batteries, and after comes the one of the most important thing, fuel cells. The fuel cells are the very important in this topic, fuel cells. Why? Because see here, classically electricity is produced by the thermal plants. Thermal power plants are there. In those thermal power plants, the electricity is produced indirect method. That is produced by indirect method. Indirect method means what? We use the sum of the materials as a source. Source are fuels by the combustion of those compounds like coal or fossil fuels. By combustion of those compounds, what happens? We are going to get the enormous amount of the polluting materials, environmental polluting materials. So in that thermal plants, what happens? We burn the fuels like coal, like that. So coal or wood, like that. Some fuels are burnt. Here during that burning, what happens? The chemical energy of the compound is converted into heat energy. That burning means what? If the compound is burnt, that fuel of the chemical energy of the compound is converted into heat of combustion. By using that heat of combustion, we boil the water. By using the heat of combustion, we boil the water. After boiling water, it forms a steam. The water is converted into steam. By using the high energy steam, the turbine cycles are made to rotate. On rotating turbine cycles, you can generate electric current. On rotating the turbine cycles, you can generate electric current. But the problem is to get heat of combustion, to get the heat for the boiling of water, the large number of the high amount of fuels are burnt. So that causes environmental pollution. And also one more important thing is, these thermal power plants are not more efficient. Their efficiency is very least. So in that condition, what we are getting? We are getting lesser amount of energy by investing a larger amount of fuels. So this is not efficient process. For that, and we also know that in this topic we have studied about galvanic cell. Do you remember galvanic cell? So what happens in galvanic cell? In galvanic cell, the chemical energy of a spontaneous chemical reaction directly converted into electrical energy. And why we cannot use that? We can use that as an energy source, isn't it? See here in thermal power plants, we are going to get electricity indirectly. We are not going to get electricity directly. Why? Because first we take the fuel and we burn the fuel. On burning the fuel, we are going to get heat, and by using that heat, we are boiling the water. On boiling water, what we are going to get? Steam, and by using that steam, we are going to rotate turbine cycles. So this is indirect process. But in galvanic cell, what happens? The chemical energy of a spontaneous chemical reaction directly converted into electrical energy. And why we cannot use that? Yes, we can use that galvanic cell as a energy source. See here, galvanic cells that are particularly designed to convert the energy of combustion of fuel. Energy of combustion of fuel means energy of spontaneous chemical reaction like hydrogen, methane, methanol, etc. directly into electrical energy. A galvanic cell which converts a combustion energy of fuels like methane, methanol or hydrogen directly into electrical energy are called as fuel cells. Please remember. So the fuel cell is an example of galvanic cell. In fuel cell is an example of galvanic cell. In fuel cell what happens? The galvanic cells are particularly designed to convert the combustion energy of fuels like hydrogen, methane, methanol directly into electrical energy. So in this process what happens? There will be no pollution. During this there will be no pollution, and also one more important thing is these cells are highly efficient. These cells are highly efficient. Here one of the most successful fuel cell is hydrogen oxygen fuel cell. So till today we know that the most powerful and most successful fuel cell is hydrogen oxygen fuel cell, and the reactants are hydrogen and oxygen. Then what will be the product? We are going to get water as the product, and water cannot cause any pollution. So this is the most successful fuel cell. And one more important interesting thing is that here this hydrogen oxygen fuel cell was used in Apollo space programs. Do you know about that? Apollo space programs. So Apollo space programs are conducted by the NASA. So in those programs what happens? They try to reach the surface of moon, isn't it? So during those Apollo space programs they used this fuel cell. Which fuel cell? Hydrogen oxygen fuel cell. So in that process what happened? They used this fuel cell in that rocket engine, and they have connected this product line into their water supply, the drinking water supply, because the product formed in the fuel cell is the water. So we can use the product of this fuel cell as drinking water, isn't it? So in space program, Apollo space program, we have used this, which is the hydrogen oxygen fuel cell, isn't it? And let's see what is the hydrogen oxygen fuel cell and how it works. So in this hydrogen oxygen fuel cell, in the cell hydrogen and oxygen are bubbled through the porous carbon electrode. So here this fuel cell consists of 3 chambers or 3 compartments. In one compartment hydrogen gas is inserted or it is blown off, and in second compartment, through the second compartment oxygen gas is blown. Here this hydrogen and oxygens are inserted into the middle compartment by the porous carbon electrode. So these are the carbon electrodes. They have got microporous, they have got small holes. Through that small holes hydrogen is enter into the middle chamber and oxygen also enter into middle chamber. Here the electrolyte used is the concentrated aqueous sodium hydroxide solution. Here the electrolyte present in this chamber is the concentrated solution of sodium hydroxide. Here from this side hydrogen is inserted, from that side oxygen is inserted into this electrolytic chamber, NaOH chamber. Here these two are the carbon electrodes. To increase the rate of this process, to increase the rate of reaction, what we use? Catalyst. Yes, we use catalyst. Here we have used the catalyst platinum or palladium. We have used platinum catalyst as well as palladium. Finely divided platinum and palladium are used as catalyst, which increases or which boosts the chemical reaction rate. At the cathode, the chemical reaction taken place is oxygen undergo reduction. Here at cathode what happens? Reduction reaction takes place. Here oxygen undergo reduction, O2 plus 2H2O plus 4 electrons. It gives 4 OH minus ions. 4 OH minus ions are produced at the cathode, and at the anode our oxidation reaction takes place. Here the reduction, here oxidation. Hydrogen gas combines with 4 OH minus ions produced at the cathode, and it gives water. And it will give water and also giving out 4 electrons. So these electrons are used again in the cathode process. So this process continues unless we supply the reactant, hydrogen and oxygen. So this chemical reaction takes place as the reactant hydrogen and oxygens are continuously inserted. The chemical reaction takes place continuously. The oral chemical reaction, how we can write oral chemical reaction? So here we can write the oral chemical reaction, and what we know that to write oral chemical reaction, the component or species which are present on the reactant side and product sides are cancelled out. Here O2 is here, 2H2O, 4 electrons are here, 4 electrons are also here, it is cancelled out, 4OH minus, 4OH minus, and 2H2O are here, 2H2O, so it cancelled out, 2 ones are, 2 twos are, so what remains? 2H2 plus O2, 2H2 plus O2, nothing remains here, gives 2H2O, so this is the chemical reaction taking place in the fuel cell, hydrogen oxygen fuel cell. Here hydrogen react with oxygen gives water as the product. So these fuel cells are 70% efficient. Here 70% efficient, and our classical thermal power plants are only 40% efficient. So these are only 40% efficient, and the efficiency of fuel cells are 70%. They are more efficient than the thermal power plants, and this is pollution free. The fuel cells are pollution free. Okay, so this is about the fuel cells, and nowadays a large number of fuel cells are fabricated, and on the test basis they are using in the automobile engines. So, and soonly we will discover a new type of fuel cells which are much efficient than these fuel cells. Okay dear students, thank you so much for watching, and please don't forget to share, comment, and don't forget to subscribe. Okay, thank you.